live. So today I'm going to talk about the basics of lists. And so let me just give you an example. So a list is just a collection of elements. So we could do a list of, one, two, three, four, five. And so here we have 6 elements in the list. We can take a look at that list, print X, and we get back our list 0, 1, 2, 3, 4, 5. And we can also look at the type of the list. So if we look at type of X, we're going to see that it's a list, which is kind of one of the key data structures. But what you can think about a list is it's kind of like an array, but it's not an array in the mathematical sense, as I'll explain in a second. It's more a collection of items. So again, if we have our list, we have 0, 1, 2, 3, 4, 5. We can look at different elements of the list. So if we want to look at the first element, we're going to use the 0, right? So the indexing in Python lists is 0 is the first element, 1 is the second, 2 is the third, 3 is the fourth, 4 is the fifth, 5 is the sixth, and so on. It's kind of why I did the 0, 1, 2, 3, 4, 5. So if I print x of 0, I get 0. But if I change this to x of 2, I get x of 2. So it's one of the ways to kind of access different elements of the list. We can also change the values. So if I come back to this little bit of code, initially I print x, and maybe I want to set x of 2 equal to 10. And then I can print x. And so we have our original list. And then I have my modified list where the third element, right? So this is the third element because we start with a 0, has been changed to 10. One thing to note is I have to, when I access an element using these brackets, here we have 6 elements in our list. If I try to go to the 6th element and maybe set that equal to 1, it's going to give me an error, and it's going to say list assignment index out of range. So we have to stay in the range. So I could go x of 5 equals 1, and then it's fine. And then again, I could print x, and I see the 3 different lists where I have the original list. I make the modification of 2 to 10, and then I make the further modification that the 5 position is 1. One thing to get a sense of the size of the list, we could also print the length of the list, and that'll tell us that we have 6 elements in the list, but again, we have the indexing going to 0. So one additional factor of a list, we can also do slices. So let me start with my list, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll do 10 elements. So if I take a list, and what I can do is create a sublist from this list. So I can say maybe I want to start at the 1st position and go all the way up to, but not including the 5th position. So basically what this is going to do is going to grab this sublist right here. So I'm starting at 1 and I'm going up to, but not including 5. And so if I print this, I get back that list 1, 2, 3, 4. So some other tricks, if I want to have a list and I want to just start at the very beginning, I don't need to put 0. Like one way to do it would be 0. I could just do colon with no value, and then maybe I want to go up to position 6, but not including position 6. I run this, and I run all the way up to kind of everything up to 6. And where there's no element, it means we're starting at 0. And likewise, I can do this backwards. So maybe I want to go from element 5 all the way to the end. So I can just do x 5, and that's going to take me 5 all the way to the end. One extra feature is sometimes you don't know what the length of your list is. So we can do x of -1, and that's going to grab us the last element of the list. And that's going to be 9. And then if I further add to that, say x of 2, we're going to get back the second to last element in the list. One last thing is we can also do strides. So I can print, and I'm going to do colon. So what that means is I'm going to start at the very beginning. I'm not going to add another thing here. Well, actually, let's go up to 6, position 6. So this is going to grab this list. And then what I want to do is stride by 2 elements. So rather grabbing every element, I'm going to grab every other element. So I'm going to step by 2. Whoop. Oh, I forgot to put the x there. I got a little bit ahead of myself. Actually, let's go up to 8. And what you're going to see is it's going to take, first of all, this list, right? So that's 0 to 8, right? From colon to 8. And then I'm going to stride every other one. So I'm going to go 0, 2, 4, 6. But then I stop there because if I try to stride another 2, I go outside the range specified. I could also stride by 3. And again, I'm going to go 0 to 3 to 6. And then it would jump to 9, but I'm not going to jump 9 because I'm stopping right before the 8 one. But if I wanted to do the whole list striding by 3, I would just do colon, colon, 3. So these are some of the different things you can do. Obviously, we can also do, print x of, say, 1 to -2. So that's going to be 1 all the way up to -2, which is the position 8. And that's going to give me this sublist from 1 to 7. All right, so we got 1, 2, 3, 4, 5, 6, 7. So that's kind of the accessing of elements in a list. One thing is a list, if I make another list, I can put numbers in it, but I also can put text. So I can put text. I can put actually another list in it. So 1, 2, 3. And maybe I'll put my name here, Chris. So that's my list. If I print the list, you'll see the different elements of the list. So we can basically stick anything in a list. So here, first element, second element, third element, fourth element, fifth element, sixth element. So if I was to print x of 3, I'm going to get back the text. If I come back to this one, print x of 4, I'll get back this sublist. Now, if I wanted to access elements in the sublist, I would actually, x of 4, you could think about as a variable referring to this list, and then I can use the rules to get different elements. So if I wanted to get that 2, I would print x of 4, comma 1, and that's going to give me back my 2 command. So you can do lots of different things with lists. One last thing is maybe from math, import sign. You can also stick functions in it. So I already mentioned you can set variables equal to functions. But what I could do is say x is equal to 1 to sine 3. And then if I look at print x of 3, which is the sine function, whoop, I did the wrong one. I meant 2. All right, forgot about the 0 indexing. I'm going to get back in the built-in function sine, right, because that refers to kind of the sine function. And then if I wanted to run the sine function, maybe I could do what's the sine of 3. And then I'm going to get back 0.1411. So you can basically stick different functions into this list and then access them using this index operation. I can't think of an immediate application, but maybe later you'll find it useful. So a couple more things are the operations of lists. So if I have x is equal to 1, 2, 3, and then maybe I have y is equal to 4, 5, 6, 7, I can do algebraic operations or simple ones. So I can do x plus y. And this is not a vector operation. First of all, these aren't even same size arrays, so you couldn't even think about adding them together. But when you do the add operation, what it does is basically it joins these two lists. So x plus y is going to be 1, 2, 3, 4, 5, 6, 7. So we're kind of adding it. And then if I did y plus x, I'm going to have that 4, 5, 6, 7, 1, 2, 3. One last thing is if I did 2 times x, what this is going to do is take this x. Well, we can think about 2 times x as being equivalent to, right, mathematically, x plus x. And so we're going to join those two lists. And so we get 1, 2, 3, 1, 2, 3. I should make this a little bit cleaner, put print statements to show all the different operations. And so again, the first one, I'm adding the two, joining the two lists. Here I'm joining the two lists in the opposite direction. Here I'm making a replication of the two lists. This is kind of useful because maybe you might want to do something like 10 times, list of 0. And here you're going to make a list of 10 elements that all have the element 0. So you're kind of like pre-allocating that list. So that's sometimes a useful command. One extra thing is if we do x is 1, 2, 3, 4, 5, we can ask a question. So we can say 3 and x, and we can print this. And that's true because the element 3 is in our list. But if I did as the element 6 in the list, That's going to be false. We can also do this with more complicated functions. So I could say y is Chris, 1, 2, 3, and maybe text. And then if I also print, is Chris in y, our list, that's going to be true. Obviously, this is case sensitive. So if I come over and put my capital one, it's going to be false. But I can come over here and do text in it. Oh, I had text. So text. And so that would be true. So you can ask questions about the list. One extra thing that's useful is the append command. So if I have a list, and sometimes what I'll do is I'll just start an empty list, which is here, and I can just print x, right? So I can print x, and it's just an empty list. And if I ask what the length of that list is, right, it's going to be 0 because there's no elements in it. So what I can do is I can do x append, and I can maybe put 1 there. And so now if I print x, I got that 1 element in it. And if I did it again, right, and then I print x, I'm going to have 1, 1, and then I can copy this, maybe put x append 2, print x, I keep on mistyping that, lowercase x, and I get 1, 2, 3. So basically we're starting with an empty list, we're adding the 1 element to it, we're adding another 1 element to it, we're adding another 2 elements. So we're just appending to that list. If you go in the documentation, you can actually append in different locations. I'm not going to show you in this video because typically when we're going to append, we're just going to append it at the end. So with that, I'll stop. This is just kind of the basic mechanics of lists. We're going to use them a lot. And in the next lecture, I'll show you how we can use lists in kind of a looping operation. So we already covered the while loop, but in the next lecture, I'm going to cover the for loop. All right, thank you. And again, if you have questions, post them to Piazza or put them in the comment section. All right, thank you.